Okay, this is a quick review. I'm going to go pretty quick through this. Little review warm up for the quiz we're about to take. Find the measures of all the angles and the all the triangles. Now, on your quiz, it's going to be multiple choice. It's only going to ask you for some of them. Hopefully, you know where the angles are. So, if I wanted you to find angle XMA right here, it would be, since this is isosceles, it would be 74 because the angles are all the base angles of an isosceles triangle are congruent. And then you could find this angle up here called the vertex angle of that triangle right there by doing 174 plus 74, which is 148, and then subtracting that from 180, which would give you 32 degrees. Now, so then if I asked you what is angle XAM, that would be 32. If I asked you what was angle MAR, that would be right here. This one's 30. This is an isosceles triangle, so this would be 30 as well. Then I could ask you what angle ARM is, ARM, right here, by saying 180 minus 30 minus 30, and that would be 120. Now, you're going to have the same picture, but you're going to have different numbers, so you got to know how to do this. All right, then let's say I gave you that angle FMR was 150 degrees. And then I asked you to find angle FMX. So if I gave you FMR, that would be this entire angle here. FMR would be 74 plus 30 plus whatever's right here. So what you would do to find the angle that I'm asking you to find, FMX, right here, is you'd take FMR and subtract 74 and 30. Oops. Okay, that's 150 minus 104, and so that would come out to be 46. Okay, and then this angle would be congruent to this angle because that's isosceles triangle up there, and you could actually find angle XFM as well. And how you could do that is 180 minus 46 and 46. And I'm not saying you're going to have to find every one of these angles, but I could be asking you any of them. Okay, so that would be 88. If you did 180 minus 46 minus 46. Yes. I made it up. Yeah, I'm telling you there's going to be a question that's going to give you like either FXA or FMR. Then you're going to have to figure out the angle that's here or here. One of those. Okay? All right, so that's just a little numbers game with those isosceles triangles. You got to know the base angles are congruent and where they are. All right, number 2, if you're given that this is an isosceles triangle with the vertex angle being angle B, vertex angle is the one that's made by the congruent sides, so these would be the congruent sides. The base angles would be congruent here and here. Okay, but what we're going to use is the fact that the sides are equal. So we would do 5x plus 5 equals 2x plus 20. Okay, and you guys know how to do this algebra. Subtract 2x. I'm not going to show every step. Subtract 5, divide by 3, and we get x is 5. And then you would be plugging back in 5 in here to tell me what the length of the sides are. I don't even know if there's a question just like this, but it could be. So 5 times 5 plus 5, that'd be 30. And then 2 times 5 plus 10, this would be plus 20 would be 30. And then the 9 times 5 minus 5, that'd be 45. Sorry, minus 5, and that'd be 40. Okay, so if you had to plug back in, you might need to give me all the sides. Okay, number 3, you've got another isosceles triangle situation over here. These are those problems that we didn't do on the review packet that I gave you the other day before the quiz 1. And so I just made sure we had it by making a different worksheet. Okay, so this I think was like number 10 or something like that on the other review. So if this is isosceles, the angles that are equal are here and here. You need to know that. That's 66 then. So angle 1 is 66 degrees. You could find angle 3 by the fact that this is a triangle and the sum of the angles is 180. So I'd take 180 minus 66 minus 66. That's 180 minus 132. Should be 48, right? Yeah, 48 degrees. And then I'll put that here. And now I can find angle 4 because these are a linear pair, or you could add the remote interiors, 66 plus 66. Either way, 180 minus 48 is going to give you 132 for angle 4. And then you can find angle 2 by the fact that this triangle down here has two angles given, so you'd do 180 minus 132 minus 24. And that's 180 minus 156. Should be coming out to 24 degrees. Yes? Okay. All right, next. This is the same kind of idea. You've got, except that this time you're not given one of the base angles on this triangle. You are given the vertex angle. The vertex angle is not equal to these two, so I want to find those two. So I do 180 minus 92, and that's 88. And then I divide that by 2, and that'll tell me that angle DAC up here is 44. Oh, it said to find CAD, that's 44. Find angle ACD, that would be down here, it would also be 44. Okay, and then I want to find the measure of angle ACB, which would be adjacent to that 44, so it's supplementary with it because that forms a linear pair. 180 minus 44 is 136. Yep. Okay, so if that's 136, now you've got to find these two angles, and it says this is isosceles, so these little guys are equal. And I would do 180 minus 136, which of course is 44. And then you divide that by 2 to share amongst those two angles, so they'd be 22 apiece. So angle ABC is 22. Okay, these kind of questions were from section 4.1 and 4.2. All right, now these are from our other sections where we talked about congruence, triangle congruence. Mark any shared sides congruent and then tell me what theorem or postulate allows you to prove the triangle's congruent. This would be two angles and a side that's not between them. So this would be angle, angle, side. What would number 12 be? Shared sides. Side, side, side. Okay. 13, side, angle, side. And 14 is not possible. And the reason it's not possible is these angles, these sides are not equal to those sides. They have different marks on them. And I want to remind you, if I had one like this, and I'm just making something up, guys, what would that be? That's HL. Okay. Hypotenuse leg. Don't assume just because it has a right angle and a triangle that it's hypotenuse leg. You need to look. It has to be hypotenuse and a leg. Okay, now we got a few proofs I'd like to quick go through. Just to get you warmed up for the ones you have to do today. Angle B congruent to angle D, mark the diagram, and that was given. It says to give us, put down the next given, so I copy in angle BAC is congruent to angle DCA, and then I go mark it on the diagram. BAC would be up here, double arc. DCA would be down here, double arc, since I already used a single arc on the other angles. All right, now I'm out of my givens, and then it hints to me that the reason is reflexive, so I should go to the picture and find something reflexive, and that would be AC congruent to itself. Segment AC is congruent to segment AC or CA. It's technically CA. And now I'm going to write the triangle congruence because of that hint. Angle, I'm going to do triangle BAC. And then if I started with B and went to A and then to C, I'd need to go to the other triangle and start with the corresponding angle, which would be D, and then CA. DCA. And the reason, oops, I forgot to mark my shared side. Oh, that's better. Now I can see it. An angle and a side. So that's angle, angle, side. If you wrote SAA, I wouldn't mark it wrong. But we're not done with the proof. We were trying to prove that these pieces are equal. So now they are. This side's equal to this side, and I'm not going to mark it because it's what I'm proving. That's by corresponding parts of congruent triangles are congruent. And you will have a CPCTC on the quiz. Okay. All right, number 16. AB is parallel to CD. I'm going to highlight those parallel sides. Okay, it says those are parallel. That doesn't mean congruent, so I'm going to get rid of that little mark. I'm going to leave that just, and then I'm going to highlight this transversal, just so maybe I can start looking at or thinking about it when I get to writing something about what happens if those are parallel. We're also given that AB is congruent to CD. So I'm going to mark that on my diagram, single slash on those segments. And then we're also given that C is the midpoint of segment AE. If C is the midpoint, then it cuts that side in half. So I'm going to go ahead and mark AC congruent to EC, or CE, excuse me. And I'm going to look for that in the proof. Do you see it? It just doesn't happen to be right after this line. It happens to be down here at number 5. So it's there. I just like to remember to use my midpoint, so I went right to this. It doesn't matter that these are not necessarily in the order you might have put them if you were doing it. So AC is congruent to CE. I'm going to write by definition of midpoint. Okay. All right, now I'm going to go back and say, all right, then it says angle BAC. Find it, BAC. A is the middle letter. That's where the angle is congruent to angle DCE, that would be here. Why? Oh, those are corresponding, so what you write is, if you have parallel, then corresponding angles congruent. Okay, great. And now those triangles are congruent by a side and an angle and a side, side, angle, side. And I think that's what we wanted to get done. Yep, there's no more parts after that. If there was something more that we were proving, it would be CPCTC next for corresponding parts. But we're not. Okay, 17. Got 2 more. C is the midpoint of BE. I'm just going to, oh, okay, well, let's see. BC would be then, I'm going to use it right away. C is the midpoint of BE. That's given. So I'm going to mark BC congruent to EC. And then I check if it's already in the proof, or I put it in the proof. Okay, it's not, it's already down here, right here. So number 3 is going to be our definition of midpoint. Okay, now I go back and I say, all right, angle B is congruent to angle E. That was another given. So I need to mark it on my picture. Angle B congruent to angle E. All right, I'm out of the givens. You can't assume that C was the midpoint of the other segment. You can't do that, so don't do that. What can I do by looking at the diagram? Chloe? Go ahead, Chloe. Mark the vertical angles. All right, you want to tell me what they are, Cadence? Because I saw your hand up too. Oh, careful. BAC would be down. BAC would be here. Great. Angle BCA congruent to ECD. Great. Okay. Make sure we remember where our middle letter needs to be where the vertex is. Okay. And that's by vertical angles are congruent. Okay. Next. Oh, I see 3 sets of parts marked on my picture. So I'm ready to say some triangles are congruent. Okay. Darylyn? Yes, go ahead. Okay. Okay. By angle, side angle. Yep, ASA, because the side's between the 2 angles. And then don't forget, you're going to have one where what you're trying to prove is not just the triangle. So I got to remember to put what I want to prove. Angle A congruent to angle D at the last step. And that would be by corresponding parts of congruent triangles are congruent. CPCTC. I bet you're glad you don't have to write that out. Okay, one more and we're going to be ready for our quiz. These triangles do overlap, but it's really very clear what we're talking about in them, so I don't need to separate them. And you don't have to on the quiz, I'm pretty darn sure. All right, segment AB is congruent to segment CD was given. Slash on each of those sides, please. Angle BAC, find it, BAC. Now that's that whole angle right there. And then DCA, D to C to A, that would be here. Given. Ooh, weird word, given. Then it says AC is congruent to AC. Why? Yeah, reflexive. All right, and now I can go for some triangles. I'm going to do triangle BAC. It's congruent to triangle DCA. And this, from our picture, side and an angle and a side. Side, angle, side. And now the rest of the parts are congruent by CP, CT, C. Okay, it's quiz time.